Thank you. Welcome to the session, and I think it's the last spot, on of the summit. But hope last but not the least, I think you guys have heard a lot about the technology, developments, advance, through the summit. And for me, I think I try to share my view from more like a use case perspective, right? So the talk is about transportation and at a city scale. And I'm from Asiainfo. My name is Jian. For those who don't know about Asiainfo, I just want to give you some very brief background. And the company got started actually from the US by a few founder back in 1993. And actually, the company is now the largest software provider in the telecom industry. So after a few years, I don't want to go through the history, but Asiainfo Data is actually a sub-company within the group, Asiainfo Group, who's mainly do all the big data offerings for all the telecom verticals. And because we serve mostly in China, and we serve 1 billion telecom users, and we process almost 1 petabyte of data every day. And we consider ourselves as a big data company in many ways, and we do have a lot of products and offering in this respect. So I'm going to talk about transportation today. That's like a small kind of like a branch from the main playfield of the company, but but you will see why we are interested in this area. And to me, transportation is something really interesting. Like we all, use our phone and the computer. We are in front of the screens every day. I think, traffic is something that reminds you are still in the physical world, right? You are not always, you are not entirely digital, by many sense, and it affects both people and the business. And here the Bay Area traffic is particularly bad, and you need to pay your insurance, deal with your traffic ticket, and many things that affect every day of your life. That's for normal people, and definitely for business, all the routing of the product and the goods and everything. That's really really critical part of our life. And a good, ideal transportation is very simple to me. It's just getting the person or the thing, to its destination in the most efficient manner, right? Safely and also. So if you want to do anything about, transportation, I mean, it's a public thing, right? And you need a lot of support. And we all realize nowadays, it's not just about policy. And it's really about technology, and big data and AI is really part of the national strategy, because the company operating in China that's part of the Chinese government's policy. And they put a lot of emphasis on not only the technology, but they realize they need to build like an ecosystem. It's a many parties play together, not only the government, but also the industry, many other parts as well. So yeah, that's actually the background, of how nowadays China view this type of technology and things. And go back to the city that we are talking about to set up a kind of another broader background. The city is called Wuxi. It's actually, you can see the blue color right on the map. Is very close to sea, and it's a relatively rich and developed area in China. It's very close to some of the major cities like Shanghai. It's a southern part of China. And one really advantage of this city is it is a national center for sensor network innovation. And there are a lot of industrial parks, manufacturers actually in the city. So I mean, it's a very good environment to fostering the entrepreneur and the talent, in terms of IoT, AI, and you all come together, right? And another thing is they are one of the first city who trying to do something smart in transportation. This is RFID is trying to bring some electronic identification for vehicles. That's just kind of the background. And one thing for those who might not know, the city actually hold IoT Exposition every year. is I think one of the pretty major event, for IoT. So for last year, for example, there are like more than 500 companies and institutions, from all over the world. They all come and showcase their solutions and the new developments. All the big names you have heard or not heard, from US and China everywhere in the world. So it's a really, really big thing for the city. And that's the technology part, and the transportation is really the playground. So so talk about how my company get involved and how we view the thing is so to do a smart city, smart transportation project, you definitely need a lot of strengths all coming together. So Asiainfo, my company, we are very good in we think we are very good in system development, integration, software stuff, big data stuff. But that's not enough, right? We actually get a lot of support from two of our major partners. One is China Telecom, which communication network providers. So because if you want to do IoT and all this stuff, there are a lot of infrastructure works need to be done, and all the underlying cables, fibers, and everything, right? So China Telecom is actually very, very useful, players in the field. And the other partner we have is one of the research institution, but the institution is a transportation management and a research institution. The institution itself is physically located in the city, and it is in charge of many of the standard creation, and it's very influential in China, and it's actually under the Department of Public Safety. So yeah, so to do this kind of innovation work, it's not like, hey, you do like a side project, you just technology, use the most innovative things or the fastest, smartest, but also there are a lot of standard, because it actually affects all the policies and everything in the city. So that's why, yeah, we have all these three parties play together to push the project. It's actually very important. So before we think about the project, I think in this conference, a lot of people talk about technologies. And actually, another really, really important thing is thinking in terms of data, right? So that's why when we first think about the project, there's a good example like the City of London that we really want to learn from. So just like everything, every items nowadays in the world is creating a lot of data, and city is no different, right? So and the first thing, if you want to do any big data project, actually, I think the most important part is not have the most advanced technology, but actually to have a very clear and very good data strategy, like how you're going to collect all this data, how you're going to open that to the partner to use all this data. And London is really a good example. That's why in the city they try to collect all this information and make it into either API or data set and share with all the partners who may be interested. So yeah, that's a very, very good example that inspires us to do the project. And another just another example, I want to just change the mindset when you think about smart transportation is, nowadays the sharing economy is very popular, right? And in China, because a lot of people ride bikes, we have the shared bicycles, right? It's a big thing, especially in major cities, and for you to get between subway stops or public transportations, right? It's a connection piece, and for the shared bicycle, actually, if you think about it, it's actually an ecosystem, right? And you get all the, great piece of IoT and big data which it promises. Like all these bikes, they are smart bikes, right? They have all these devices like GPS, all the sensors, installed on them. So that's part of due to all the manufacturers' work. And of course, those bikes, they need to communicate. Not only communicate with the central network, but also with the user, right? So the usage scenario in China is like you have your almost all the people have their smartphone, right? They open their smartphone, they open the app, and there's some QR code on the bike, and they can just scan the QR code, and if they check validation or the process works, the smart lock will just unlock the bike, and you can just use it. And once you finish, you can just simply log back, and they will charge you, based on the amount of time you used back. And it's also touched, all the, share bike platform, and also the user, and also the payment. So it's an entire ecosystem. But because we have all these bike and the user, these smartphones and smart bikes, they are collecting, information, sending data over the network, and you have all the information on the time and the space, all the characteristics, all the features, so you can actually provide a much better service, because of the data. I think that's actually the goal, right, of doing the smart transportation in the city. So another perspective is to think about transportation is also not just about vehicles, and it's actually trains, and not just cars, right? Trains and bicycles and flight and ship. Especially when governments think about it, I mean it's the whole thing. It's not just we want to have some self-driving cars, and that's just a small part of it, right? And just trying to bring this into perspective. So. This is a kind of functional architecture, how we view the thing, right? As a this is pretty much like the architect you will have in any, I would say, some like big data or data-driven company, right? So definitely at the underlying, the fundamental pieces is the, the edge node where you collect all the information, right? And then all the information being collected and will be fed into your big data center, your warehouse, and that also form as the part of the city brain. And I would think brain as not only information storage, but also processing and make sense out of it, right? And at the top level, it will be all your applications, right? That either support either the administration part or people who use the transportation as a service, right? And of course, all these are the users, and it will drive better public safety, smart city becomes smarter, and enable a lot of other verticals to grow. And on the other hand, there are research going on. There are a lot of technology innovation, data service being provided through the entire the entire system. So going back to the IoT part, so I think when people talk about thinking about collecting data and using sensors, I mean that's what people would think, right? You place some sensors in the on the road or in the cars or on the phones, but actually in terms of smart city, one of the most rich source of data is actually video. So and using nowadays we call AI, but computer vision, whatever technology you have to make sense out of this very rich data source is actually very critical, because video does have its very unique advantages. And I don't know about here very well, but in China there are many cameras right on the road for different purpose, like for safety, for little bit monitoring, like parking lots. There are all these kind of things, and to process all this data is not a tedious, it's not a trivial task, and it requires a lot of processing power. But technology does evolve a lot, over years. Like I just want to give you like an example of what can be done now. For example, previously, maybe 10 years ago, people care about the plate, right? They want to see what's exactly a number on the plate, right? So they can just do, optical, letter recognition, so they just care about the letter. But nowadays, they actually can, see, what's the model of the car, what's in the car, all sorts of this information. It's like hundreds of dimensions of features, right? So even on one frame of the image, you can have very rich information. And that's why, I mean, of course, recently due to these 3-4 years, the hype of deep learning and everything, right? And but just keep in mind, I mean, if you want to do this in a city scale, you probably won't be able to really do like all your your video processing in a DGX1 or 2, because that's very expensive. So nowadays, what people do is pushing all the computing capabilities into the edge. Like they are very specially designed chips. Actually, is part of the camera, and it will just extract all this feature automatically, and the structured data will be sent back to the as the output of the camera to be used later. And I'm just giving more examples, like, they can know the type of car, the made, the type, and also the features, the colors, and everything. And so not only the car types, and they can know like who's driving in the car and everything. There are a lot of other, scenario. This is real. This is not like a, sci-fi scenario. So not only cars, but also like people, right? So especially in China, there are a lot of major cities. They are, these very crowded subways and entrance, exit. For many purposes, they have this, recognition, like functionality in the camera for security purpose mostly, right? Who's entering, how many people are entering, like the male, female, gender, age. You can get a pretty good detection accuracy nowadays with this technology as well. So like that's definitely one way of like collecting information. And another, I just want to for the next few like 20 minutes or so, I want to give you a more understanding of a few highlights that besides big data and what we actually done, which I think is kind of interesting, right, to share with you guys. So there are like three major parts. I will go through them one by one. The first part is as I mentioned like before, Wuxi is a city is a pilot city for trying to push the electronic palette for vehicles. So it's a RFID-based. So the motivation is like, although we have this very nice, very useful AI technology who can watch the car just like a human being standing there, right? See, hey, what's the number and characters on the plate, but it may be fake. So to really way from an administrative perspective, if they really want to have some absolute certainty, they need to have some other mechanism, and that's why they are pushing this E-Plate technology. So it's actually just a RFID tag that you can paste on the front sheet window of the vehicle. And the research institute I mentioned previously, one of the partners, is actually the standard creator of this technology. So there are, so as you understand, it's not only the tag, but also you need to have all the manufacturing to do the car reader, right? Like when the car passes in like certain speed, you need to make sure the accuracy of detection and everything are good. And also, the whole thing need to work in very hot weathers or very, very freezing weathers as well. So there are a lot of like testing, going on for the thing. And this is like a more like a administrative scenario. Like so basically you bring your paperwork, to the in the US like DMV kind of thing, right? They will issue the tag for you, and in the tag you can only store the ID, right, or the plate information of your car, but it can also store a lot of other information like the make and everything, right? And they will issue the tag for you, and there are a lot of encryption going on for the information in the tag, so other people can now easily read without a proper authorization and everything. And the tag is also like specially made so that you cannot transfer. So basically the policeman will paste the tag for you, right, on your vehicle. And if you try to remove it, transfer it to another car, it's just impossible. The tag will break. So there are a lot of source and going on for the thing. But because you have this technology and you have all these readers, right, this is trying to show, hey, for each of the line. So basically the reader are designed to only read one line, of the vehicle. And so in the city, we have already, deployed for, almost 200 set of this kind of reading equipment that covering like all the major intersections in the city. And because it's a kind of trial, so we first push it to all the like bus and taxi, this kind of public transportation thing, and like also trucks that carry, some potentially dangerous chemical thing, right? So as a first experiment. And there are many usage of when you have this kind of information, right? The number one thing, as I mentioned, you can know, right, if the vehicle is using a fake plate, if the video information doesn't match with the ID, right, being read from the tag. That's one thing. The other thing is nowadays, especially in major cities, they need to control who can use which road. Like just one example, like the bus, right? There are many cities now, they have like a dedicated bus lane just for bus, like within certain hours the other cars just cannot use the lane. And this is one way to implement that. And definitely you can track the trajectory, collect information, do all your, planning, routing of the vehicle as well. Another thing is, especially for some very congested area, people are proposing the idea of, if you can use the road, but people will charge you, right? So if you, definitely if you have some payment method bind with the ID, so if you are in the area like within certain period of the day, they will charge you automatically. That's some useful scenario for this particular technology, right? So the second part, what we do is we like to help the government to develop a portal, the app part. So that's like for the end user to use it. So as you can see, Chinese, I know, but I will try to explain. So, so the thing I show here is the bus information, right? They can tell you exactly which bus transport you can do if you want to take subway or bus. The second part is for all the administration work. You can also do in the app as well. Especially there are so many cameras, like the police department placed, and they can allow you to see those cameras if not sensitive information, to see the what's going on certain intersections through the app, and you can pay your ticket, whatever, in the app as well. They will also tell you some real-time alert, but it's from the official. It's not like cross-sourced the information. And also not only that, but also it try to connect not only the vehicles, but also like bikes, and the later two part is actually the plane information, to get people from one place to another, like consider the whole transportation system as a whole, right? So the other part is like parking, gas, the real-time road information, all in one app. It can be very, very useful for the end user. So the next part is for the connected vehicle. I think that's something. It's very experimental, but I think it's maybe interesting to share with you guys. So the goal is, when I was doing my PhD like 7 years ago, I'm already the research on connected vehicle, V2V, V2I research is already very popular, especially from the network research perspective. So there are some really unique advantage for vehicle to communicate with each other. The number one thing is it's not like a cell phone, right? You have enough power, I have enough space, and it just works, right? It's for cars to communicate with each other and not go through centralized, for example, people will ask like, hey, why don't we like just carry a cell phone, everybody talk to a centralized place? Because that's very, very inefficient. It's very hard to do real-time guarantee. For these kind of things, you want to be communicated really fast and only within local, vehicles. And there are many, usage of such service. Like you can provide a solution, the vehicle will get very updated information, everything, right? I will try to go through a few of the things we do, and there's a video at the end I can show you to see, what's really being done. And weather information, all these information are very useful to be propagated within the networks. And currently, there are actually two, protocols or technology being pushed out, for like a V2X communication. And there's like a more US, standard, Europe standard, which is the SRC. I think widely used in the ETC and some of the technology to use this to charge you. And there's another kind of another type of technology more from the communication provider. It's the 5G LTE. And there is as I mentioned, right, there's like an industry, association, like from car makers, from like Intel, Huawei, which are the the network device makers, Qualcomm, and they are pushing another standard, which is the 5G LTE standard. And that's the technology actually we choose and use in our experiment. So what we do is we actually collaborate with China Mobile and Huawei, which is phone maker, telecom device maker, and Audi, which is a car maker, and the department the Wuxi Police Department to run some pilot experiment of the connected vehicle in Wuxi. So they actually have a very dedicated play field, and there are certain roads are just built to test these kind of vehicles. and just for safety purpose, right? And there are two things. For V2I technology, is mostly about the vehicle to coordinate with the road. I will show you what does it means. And the second part for V2V is more about like emergency situation. When the car behind you want to go faster or something, for coordination in that sense. And for the V2I, what you actually do is, because you can actually communicate with the infrastructure, then you can know a lot of information in advance. For example, you will know maybe even 2 minutes earlier that there will be many cars in front of you, and which line have how many cars, and when you reach there, probably you're gonna hit a red light, so you probably don't need to accelerate now. There are many different can be communicated through the vehicle and the infrastructure, and this one is showing you can have some device, especially manufactured just a plug-in device. You don't need to change your car. It's just like a smartphone kind of thing, right? But it's running the protocol. It will talk with the infrastructure and everything, and it will give the information to you in a real-time fashion. That's that. And the other thing is, once you have this coordination, what can happen is, if there are certain emergency, certain vehicle must go to a certain place within a specific time period. So what they can do is they can only give red light to the car when the car arrived, and all the other vehicle can just wait. So they can do this kind of coordination, and they can plan the route, and while the car move along the route, they will change the traffic light and control that properly. So this also implies you need to have smart traffic light controller as well. And there are a lot of you all know Uber, right? But there's another company very similar, doing similar things in China called Didi, and they are also in the field. They are trying to make a smart traffic light, and because they have a lot of data as well, they know exactly there are so many cars running, right? They're like the Uber driver, think about that, right? They know exactly when it's crowded and everything through the app information they collected, so they can do planning and everything. They are in the field. I mean, not saying making a lot of money, but they are actually pushing to do things like that. So another perspective is the V2V perspective is once you have the car, and what I show here is actually the dashboard. This is a specially made Audi car, and with all the communication component already assembled properly in the car. So you have the communication capability, and it will show the information on your dashboard. So once for example a car behind you want to pass you, or a car in front of you, they have hit a very hard brake, and you will know that the car will be noticed immediately. And if you have some control element as well, for example if the front car stop very immediately, and you can also decelerate the car as well. So let me show you the video. So I don't think they have the audio connected, but that's okay.
公安部教科所牵头联合华为。
So they are speaking in Chinese, but I try to explain. Say this is all the players trying to do the experiment. And yes, there are the specially designed area and road, and you see the infrastructure, all the signal device, Yeah, they're just saying they are trying to do V2V and V2I in this particular experiment. And this is a city, it's and because they had the RFID first, invented, they know exactly the ID of the car. So that's part of the information being communicated, also doing authorization and everything. Right? So these are the network designed for the LTE-V. They have a data center and all the network to all install. So, for example, they are trying to show the signal. You can see, right? The car dashboard can see in real time the traffic light information as well, right? So you know in advance. And you don't need to accelerate if you know there's a red light in front of you. They like guide your speed, and they know how the length of the queue for each of the intersection. Right? For example, this one queue is very crowded. You probably want to go to the switch line, beforehand. Right. And they show you can view the camera on the intersection.
当前方道路有车辆限行或进行交通管制时，
and they can tell you immediately, right? For example, there are like some incidents happen, they can tell you immediately. You can get the notification. Right, for example, they say, hey, in front there are school area and everything. Or, you get the notification on your dashboard.
前方有施工路段时，
For example, there are
交通信号机
like
将
roadworks.
施工信息
They
发
will
送
tell
给车
you,
辆，并给出
roadworks,
车辆绕
go
行
to
的
another
信息
way.
提示。当交通信号机感知到道路上发生了交通事故，
These are like there are
将会及时
accidents.
发送
They will
警示
also
信息给
let you
即
know.
将经过的车辆，提醒司机谨慎驾驶。当前方道路上有车辆抛锚时，车辆能够收到交通信号机发来的交通事件信息提醒，司机可提前做好避让。V2V 测试通过
Just
北斗
another
导航
about
系统
like the
实现车
vehicle
辆
to
精准
vehicle,
定位，
and every car
展示
have
我
a
们
very
车辆
accurate
根据
GPS
危险
installed,
预测级
so
别
they know the
进
location.
行预警的场
So
景。
you not only need the
当本
communication,
车
but you
发
need
出
to have
5AT
very
通
accurate
信请
location
求时，
information. For example, there's an ambulance or a police car behind you. They need the road. They will let you know immediately instead of doing the alarming part, right?
或
You
者
will see on
当
the
前方
dashboard.
车辆紧急制动，
And this is saying like
前
people
方
try to
刹车请注意。
brake, and they
本车
will
会收
let
到
you know
前
as
方
well.
车
You
辆
can
发来的
change
警
line
示
or
信息。
whatever.
不同方向的
And
车
for example,
辆
there's
均
in the
驶向十字
intersection,
路口
there's，kind of
注
blind
意
spot.
方向来车。
You
车辆
didn't
之间
notice
会
someone
相互发出
will
碰撞
come
预警
this way.
信号。此次测试采用的 LTE-V 解决方案，可优化现有移动通信网络，保障行车
Yeah,
安
that's
全。
that's pretty much it. Yeah. Right. Yeah, I think that's also kind of end my talk. Thank you so much. I'll show a few pictures of the city. Yeah, it's a very beautiful city, and I think with all the technology and the new experiment, it will make the transportation smarter, step by step. All right. Thank you so much. Any questions? Yeah, please. Oh, yeah. I can't hear you. I will repeat your question. I can't hear you. So the question is on the number of edge node and how the information being collected and routed, right? So as I mentioned, it really depends. For example, for the RFID, the ID card, so they have special network, and currently we are having like about 30,000 vehicles get installed, and the reader is about 200. So it's like, because that's part of the public safety. In China, at least, they have very special network, physical network to collect all this information, and they have special protocol as well. It's not, just open source software kind of thing, right? And also for the cameras, they are, because you have so many cameras, the bandwidth requirement is also pretty high, right? So they have special equipment, a special network to do this, and also, if you just share more information, and for example, all this data being collected, there's another isolation layer to the control center. Control center have its own kind of internal network and the system and everything, and information can only be flow in and not flow out. There's some like security policy around that as well. Yep. Any other questions? Yeah, please. Of like what network of the any yes, have hacked, exactly. That's why the safety is number one concern. I mean, as I mentioned, like even years ago, if you go to a security conference, there are people hacking cars without having this capability, right? So that can be potentially dangerous. And I'm from a very academia perspective, right? Like I can tell you academia solution is you need to do model checking, software verification, all these things to make sure your software have no bugs, and give proofs to make sure the certain property hold. But you know, it's hard in the real world. But yeah, it's a concern. I totally understand. Yeah. Any other questions? Okay. No problem. I can hear it. Yes. So, I mean, underlying, there are definitely, you know, technology need to be used, like if you consider as a message queue or whatever, right, you need to use new technology like Kafka, whatever, to give you the guarantee. That's there. But currently, I think these are doing the, just to tell the full stories, they are doing experiment. That's definitely not the number one concern, right? They are trying to collect data to see, you know, what value you can generate, right? And then before they push to like, but I get you. That's definitely another valid concern if you want to push it to full grade. And maybe if they realize, you know, that may not be just lost one or two message may not be most critical. For example, if you think about a car parsing the reader, it will generate many signals. Sometimes you just need to catch one or two snapshot. You don't need the continuous trajectory of the car. I mean, that also works. So it's a trade-off, right? If you want to make sure now no message lost, you need to pay the price, right? Do certain things, but it may not be important. That's another like engineering concern. So it's all new, brand new. Like, what should be the proper way to handle this in a economic and feasible way? I think that's definitely open. Yeah. Okay, thank you so much.